All right, in our last video, we talked about pH indicators. In this topic, I should say, we are going to be focusing on the actual pH scale. What do those numbers represent when we figure out what actual pH a solution is? So pH is a direct measurement of the amount of hydronium, or the concentration of it. So that is your H3O plus, which sometimes we know we'll see is just the hydrogen ion, or H plus. The pH scale is designed to help us determine how acidic or how basic an aqueous solution is, or if it's neutral. So we can look at the relationship between the hydronium and hydroxide ions in order to determine how to classify it. So a pH scale usually ranges from about 1 or 0, depending on the scale, to about 14. So most of you guys know that a pH of 7 is neutral. Anything below a pH of 7 is going to be acidic. Anything above it is going to be basic. When we talked about Arrhenius acids and bases, we talked about how acids release hydronium or hydrogen ions into solution, and bases release hydroxide. Both are actually present though in solution. It's just the relationship between them. So in an acidic solution, which has a pH less than 7, what makes it acidic is that hydronium ion concentration is greater than its hydroxide ion concentration. In a basic solution where the pH is greater than 7, the reason or why it has those basic solution properties is because in that range, the hydroxide ion concentration is greater than the hydronium ion concentration. And when it's neutral, where it has that pH of 7, these two should actually be equal to each other. So the hydronium ion concentration will be equal to the hydroxide ion concentration when it's neutral. So if you have a solution that has a pH of 9, we would know that it has a higher concentration of hydroxide than hydronium. So we know that it would be basic if it has that pH of 9. However, if it has a pH of 2 and we know it's acidic, the hydronium ion concentration would be higher than the hydroxide, and that's what makes it or gives it its acidic properties. Now, on the pH scale, every change of a single pH unit is signified by a 10-fold change in the hydronium ion concentration. So if we compare 4 to 5, and I'm going to make like a little number scale here because I think it's helpful for some students. So I'm going to have 3, 4, 5, 6, and this obviously extends in both directions. This is saying if I have a change from 4 to 5. So first off, I'm moving to a greater pH. Okay, this is becoming less acidic. Okay, so as you move farther away from 0 or 1, it's becoming less acidic. This means that the hydronium ion concentration is going to decrease. Okay, so here it's more acidic. Over here is less acidic. Okay, as you go towards 1, this means then more hydronium. And as you become less acidic, it's less hydronium. Okay, so how many times does it change though? I made one jump on the pH scale, so I know it's going to decrease by a factor of 10. Okay, let's compare these 6 to a pH of 3. Okay, so here I'm starting at 6 and I'm going to be going down to a pH of 3. So again, as you move closer to a pH of 1, it's becoming more acidic. So that means it has more hydronium in the solution. As you go up to a higher value, this is going to be less acidic. So it has less hydronium. So as you go from 6 to 3 and I'm moving to a lower pH value, that means that the solution is going to become more acidic, which means the hydronium ion concentration is going to be increasing, so it increases. And then I'm going to look at each jump. Now this is important. Each jump is a factor of 10. So this is going to be 10 times 10 times 10. Okay, so a 1, and I made 3 jumps, so it's going to be 3 zeros. Okay, it is not going to be by a factor of 30. You don't add them, you multiply them. So the hydronium ion concentration increases by a factor of 1,000. So let me show you a couple other practice questions. These are old Regents questions. So this says, which pH change represents a 100-fold decrease in the concentration of hydronium? So that decrease part is telling me that it is going to be becoming less acidic. So I should be moving to a higher pH value. Okay, so right away I can throw out C because it's moving to a lower pH value, and I can throw out D. It's moving to a lower pH value. Those are becoming more acidic, not less acidic. The 100-fold decrease, so 100, means that you have 2 jumps on the pH scale. So A has a jump from 5 to 6 to 7, B has a jump from 13 to 14. So that's where I'm going to pick A here as my final answer. So number 2, this says I have a solution with a pH of 7. An acid is added and the hydronium ion concentration becomes 100 times greater. So the greater part means it's becoming more acidic. So I need to make sure I'm moving to a lower value. The 100 times, just like in the one before, means 100 would be 10 times 10. So I have 2 jumps, or 2 integers to move. So that would move me from a pH of 7 to 6. That would be times 10. And then if I go down another one, to 5. So my answer here would be B. All right, over on the left-hand side, or right-hand side, I have a pH that goes from 5 to 8. So I'm going from 5 to 6, 7 to 8. So first off, as I move in this direction, I'm going to be becoming less acidic. So I'm going to decrease my amount of hydronium. So that's the first thing, is I'm going to get rid of A and B because I should be decreasing it. And then just remember, each jump is a times 10. So 10 times 10 times 10. I have 3 jumps, so 3 times 10. So that would give me 1,000. So my final answer there would be D. And then the last question here says, which of these solutions place in order of increasing hydrogen ion concentration? So this means I want to cause it to have become more acidic, which I'm guessing, oh, that got cut off. So this would end up being, and it looks like the option might not even be there at the bottom. If I was trying to increase the hydrogen ion concentration, oh, where it is there, you would have 10 would be the least acidic, so, or the least amount of H+, followed by 7, followed by 5. So that would be solution A, B, and C. So that would be choice A there. Okay, so those are just some examples. If you can go on to the quizzes and practice a bunch of these, and we'll see how you do.